Hello everyone, welcome back. So now the subject I'm going to be talking about is going to be relating to cloud computing. So without any delay, let's get into the video. So firstly, we have the introduction, and again this particular video is going to be dealing with one particular paper that I took as a reference for this. So introduction to what is cloud computing is basically that it is going to be providing an on-demand access to shared resources, that is server, storage and applications over the particular internet. It is going to be supporting different models like infrastructure as a service, that is IaaS, platform as a service PaaS, and software as a service SaaS respectively. So why fault tolerance is actually important in cloud computing and what is it respectively? See, it is basically going to ensure high availability and even reliability that is going to be critical for cloud services, and fault tolerance is going to allow systems in order to continue operating even if there are going to be faults present in this. So moving on, we have the methodology, that is what methods have been used in this particular paper in order to get to the result they wanted to. So firstly, we have the proactive fault tolerance. This technique is basically going to aim to predict and even prevent faults before even they occur. Strategies like self-healing is going to allow systems to automatically detect early signs of failure and take correlative actions. For instance, if a server is going to show signs of failure, it may even be preemptively replaced. Next one is going to be preemptive migration. So this is a proactive technique or a proactive technique where workloads are migrated to healthier servers when a fault is predicted. By moving jobs or applications before a failure occurs, the cloud is going to ensure continued availability and performance. Next one is going to be reactive fault tolerances. When fault occurs despite prevention efforts, reactive methods are going to focus on addressing and resolving the fault. This approach is going to include the technique such as replication, where data or process are duplicated across multiple servers for redundancy. Next one is going to be checkpoint restaurant or restart. Okay, so this reactive technique periodically is going to save the state of a process. So if a failure happens, the process can be restarted from the last saved state instead of beginning from the scratch. This is going to minimize the data loss as well as the downtime. The final point here is going to be job migration. So in cases of failure, job migration is going to involve moving across active workloads from faulty systems to operational ones. This is going to ensure that the affected task is going to continue to execute on alternative resources with minimal interruption. So the next slide is going to deal with the advantages of this particular cloud computing, or rather the fault finding in cloud computing. So first one is going to be cost savings. With pay as you go, cloud computing is going to use a pay as you go principle model or a pricing model, which is going to allow organizers to only pay for the resources they consume. This is going to eliminate the need for large upfront investments in infrastructure, reducing the overall operational costs. Next one is going to be the disaster recovery. Cloud services are basically going to provide and even ensure robust disaster recovery by implementing multi-location infrastructures. Data and other services are replicated across geographically dispersed data centers, enabling quick and recoverability in case of a failure at any one location. Next one is going to be elasticity and scalability. So the cloud is going to offer elasticity and scalability, meaning resources can be dynamically provisioned or released based on real-time demand, and this is going to ensure optimal performance during peak usage and cost savings during periods of lower demand respectively. So we have a continuation of the same, that is automatic software updates. So cloud platforms are going to enable automatic software updates, including patches and new integrations. This reduces the need for manual intervention, ensuring systems remain up to date with minimal disruption to business operations. So next one is basically reduced maintenance costs. Since hardware maintenance and software management are handled by the cloud provider, organizations save on maintenance costs that allows the business to focus on their core activities instead of managing complex IT infrastructures. So moving on to the next slide, we have the disadvantages of the same. So the first disadvantage here is fault complexity in cloud environments. Cloud environments often are going to face complex faults that involve a combination of hardware failures, network issues and software bugs. Identifying and isolating the root cause of these faults can actually be challenging due to the distributed nature of cloud systems. Next one is going to be the overhead of provocative techniques. While proactive fault tolerance techniques like self-healing and preemptive migration are going to prevent failures, they also are going to introduce extra overhead. This continuous monitoring, prediction and migration of resources can increase system execution cost and affect the performance as a whole. Next one is going to be the security concerns in public clouds. So public clouds are generally going to offer a lower level of control and security compared to private and even hybrid cloud models. Organizations may even face vulnerabilities due to shared infrastructure and external management, making it difficult in order to enforce stringent security policies. So moving on, we have the continuation to the same, that is balancing the performance and fault tolerance. Achieving fault tolerance often requires a trade-off with performance. For example, replication and backup strategies can actually consume additional resources and bandwidth, potentially affecting the speed and the responsiveness of cloud applications. Next one is going to be the complex recovery processes. When faults do actually occur in cloud systems, the recovery process can actually be complex due to the involvement of various components, including network dependencies and multi-tiered architectures. Ensuring a seamless recovery often is going to require sophisticated coordination between these elements, respectively. Moving on, we have the results, that is evaluation of fault tolerance approaches actually had reactive techniques that is effective for reducing failures post occurrence. Example is replication. Next one is going to be provocative techniques, that is superior in preserving or rather preventing faults with methods like self-healing and offering. Next one is going to be the research highlights, that is provocative fault tolerance systems. Example is MapReduce and FT Cloud demonstrate better availability and resilience in the real world applications. So conclusion here is key takeaways, that is respectfully as follows. So fault tolerance is critical to ensure high availability and reliability in cloud computing. Both proactive and reactive approaches are essential but need to be carefully chosen based on the system's requirements. Next one is the future directions, that is development of a unified fault tolerance framework that can actually handle multiple types of faults, potentially leveraging AI and machine learning. So I hope you understood all the topics that were being covered in this particular video, right from the introduction to all of the tools that were being used, the methodologies, how everything works, so on and so forth. So I hope you really enjoyed the video and thank you for watching.